the blasts pummeled the Earth's magnetic field. These historic solar storms caused auroras as far south as Florida. There was some advance warning. Only one satellite was lost. Still, there's a clear need to do better.
We can say, gee, that's a huge event, it threw out tons of energy, that's the brightest flare we've ever seen, but we still don't know how it's actually going to affect the Earth until it arrives. And then, you know, it's almost studying the aftermath of the event. And so there is still an awful lot more to understand about the sun.
With our fleet of 5 probes, we are able to gather more sophisticated data on the sun and its profound effects on our Earth. Yet only Genesis and its precious cargo may provide the answers to one very fundamental question. What is the sun made of? Since we can't sample the primordial solar nebula by scooping material directly from the sun's surface, NASA chose the next best thing. Let bits of the sun be blown towards us, atom by atom, in the solar wind. Genesis set up camp at a point in space known as L1, the same region as SOHO, where the gravity of the sun and Earth balance each other out. Here it sat, orbiting around a particular point of nothingness, while its collectors swatted solar atoms as if they were flies colliding with sticky flypaper. Onboard sensors would detect variations in the sun's activity, swinging different collectors into the line of fire, depending upon what type and intensity of solar wind was heading its way.
We flew 15 different ultra-pure, ultra-clean collector materials that the solar wind was implanted in. You can think of these materials as being the box that the solar wind is captured in.
Each collector was a work of art, an array of delicate wafers of diamond, germanium, sapphire, and silicon, materials that would hold runaway solar atoms captive inside the purest molecular prisons. After 2.5 years in space, about 1 billion atoms had now embedded themselves in the fragile array of crystalline collectors. Now, all Genesis had to do was somehow get back to Earth in one piece. Genesis was now on final approach, racing towards the Earth with its precious cargo.
You're loud and clear, sir. I see you approaching the point. The operation is normal. Still no tracks.
It was coming in from the northwest and would enter the atmosphere somewhere over Oregon.
Separation on you. You can slow down.
Mission Control had it right on course for the target area.
And Vertical Flight reported their liftoff at 2:05 passed out. We think NASA selected about 10 seconds delay.
Scientist Don Burnett had been dreaming of this moment ever since the mission was first conceived back in 1983. Now, all he could do was watch and wait.
Vertigo, Clover, loud and clear. Wind over, correction, Doug, altimeter 3009.
The helicopters were heading for their staging point, where they would wait for a visual confirmation and the signal to intercept.
Advisory, proceed as requested. Yes, 7 is crossing. 30, land. Separation on you. You can slow down.
The team was taking no chances. If Cliff's helicopter failed to hook up, then Dan's would follow in for the capture.
Copy, flight to trail.
The Earth waited. Somewhere overhead, Genesis was hurtling towards the planet at nearly 25,000 miles per hour with its special delivery. The capsule blistered into the atmosphere right on schedule at 9:52 Mountain Time.
Got a visual on the target at this time. Got a good visual on the target.
Vertigo Mach. Vertigo Mach. I have a good track now, sir. Bearing 200, 13 miles at 60,600
reports a good track and is vectoring.
And it's 13 miles out. Recommend you vector 190. 190 for Vertigo.
One of the key steps is for the drogue chute to open. That's done through electronic sensors that measure the deceleration of the vehicle. This is a very key and critical operation, and this is one of the first indications that this whole process is going to work well if we have visual confirmation that that drogue chute has in fact inflated.
Everybody waited for the parachute to open.
And Mission Manager MTC, be advised, from our vantage point, we do not see a drogue chute. Negative drogue.
Vertigo Mach, it looks like we have a no-shoot, sir. Vector 200,
Mission
put it on your
Manager,
nose, 8 miles, look for an impact.
MTC, negative drogue, negative chute.
Copy, we see the visual.
Impact at 5-8.
There was a moment of shock. When we saw it hit, everyone did stand still, and you could have heard a pin drop. That probably lasted for 30 seconds, which is a long time.
Mission Control was in a state of shock, and the reality of the crash took a moment to sink in.
5
We have an impact bearing 200, 8 miles. Copy your last 8 miles. Do you have an altitude?
The Genesis return capsule made impact with the Utah desert at over 186 miles per hour.
When the thing hit 20,000 feet, it was going so fast, and it was wobbling. I figured, oh my God, the parachute's not going to open. There's nothing outside.
This is the first time that we've sent something out for 3 years and had a parachute sitting in it and expected the parachute to open up 3 years later, and it didn't.
At the crash scene, Dr. Stansberry and the recovery team could see that the science canister was broken open. And they could see the glint of broken collectors smashed inside.
Copy, we see the visuals.
The Genesis team was putting on the bravest face they could, despite their worst nightmare unfolding in front of them.
And Vertigo Mach, we can actually see it on the...
At least, they had the samples back on Earth.
Oh no, it's definitely a good partial success. Definitely not what we wanted, but we're going to make the most of this, and we're going to get a lot out of that still.
You may have a live mortar. Do you copy that?
Well, I feel very disappointed, but we've got to roll up our sleeves and see what we can pull out of this. It could be a big mess, or we may be able to get something. I just don't think I can make any promises right now.
Okay, Bob. We're assembling a complement of tools to come out there, dig it out.
You think you're going to get another chance?
I'm too old. Maybe. Hold on. Let's see what we can do, and maybe somebody else can pick it up.
Picking it up was exactly what they did. Piece by mangled piece. Sliver by tiny sliver. Hoping to decipher the mess and find the atoms from the sun locked inside.
We had thought through the bad things that could have happened, so we were prepared for this, even though none of us wanted it to happen.
It took the rest of the day to collect all the pieces spilling out across the dirty mud of the salt pan.
First priority was to get the science canister out of the field and into the clean room before nightfall. And we did it.
The only
only words that I had for those gentlemen is a handshake and a hug, and just to tell them, Cliff and I, that we're sorry, and sorry it hadn't been a better outcome.
The crash of the Genesis return capsule was due to a failure of a micro switch in the accelerometer. It was designed upside down,
the target at this time,
so the spacecraft never sensed that it was entering Earth's atmosphere.
Impact, sir. Ground level.
And never gave the command to deploy the parachute. What at first appeared to be a total disaster gradually gave way to optimism. Dr. Stansberry of the Johnson Space Center is charged with assessing the condition of the solar samples and preparing them for the scientific community.
Every time we would find an undamaged piece or a new type of collector was exciting. We were able to every day collect more and more and get samples that we knew were going to be usable.
To ensure the safety and integrity of the samples, they are stored in a Type 10 clean room. Compared to a hospital operating room, this is 1,000 times cleaner. The atoms and ions traveling in the solar wind were embedded into the collectors at 250 to 500 miles per second, lodging themselves hundreds of nanometers below the surface.
Now, to most people, that's still the surface. That's not very far in. But to an atom, that's a long ways in. When you get to the zone that doesn't have surface contamination on it anymore and doesn't yet have anything else other than what the collector itself is made out of, then as you go further in, you'll have the solar wind.
Each collector had a known thickness, but now dirty, broken, and mixed together. The only way to tell them apart is to measure the thickness of over 10,000 individual pieces. They first need to determine the organic properties of the contamination. What compounds are found in the encrusted dirt, and how badly it scratched the surface of the wafers. They then can measure the thickness of each shattered piece to determine which collector it came from.
This is one of the half hexagons that we flew that is a gold on sapphire collector. What we're doing here is doing optical microscopy on the surface, looking at the surface, seeing what we have. The scratches and the dust particles just pop right out at you. So you can get a very quick, nice overview of the condition of the surface. The Genesis mission is a success. We have the samples here. If you have the samples, you can do the science. Each one of these missions and each sample collection that we have gives us another building block to understanding our solar system and how our solar system works and how planets evolve. So this is one of many different pieces in the jigsaw puzzle.
The Genesis mission might one day help to answer a very complex question. What happened when the sun burst into life? This miracle, which created the planets, asteroids, and the Earth. The scientific community will continue to launch unmanned probes into the heavens, focusing their instruments at the sun, collecting solar data, and searching for greater knowledge. As earthbound creatures, we have a profound need to understand the star that gives us light, that gives us warmth, and that gives us life. We are able to gather more sophisticated data on the sun and its profound effects on our Earth. Yet only Genesis and its precious cargo may provide the answers to one very fundamental question. What is the sun made of? Since we can't sample the primordial solar nebula by scooping material directly from the blasts pummeled the Earth's magnetic field. These historic solar storms caused auroras as far south as Florida. There was some advance warning. Only one satellite was lost. Still each other out. Here it sat, orbiting around a particular point of nothingness, while its collectors swatted solar atoms as if they were flies colliding with sticky flypaper. Onboard sensors would detect variations in the sun's activity. So there's a clear need to do better.
We can say, gee, that's a huge event, it threw out tons of energy, that's the brightest flare we've ever seen, but we still don't know how it's actually going to affect the Earth until it arrives. And then, you know, it's almost studying the aftermath of the event. And so there is still an awful lot more to understand about the sun.
With our fleet of 5 probes on the sun's surface, NASA chose the next best thing. Let bits of the sun be blown towards us, atom by atom, in the solar wind. Genesis set up camp at a point in space known as L1, the same region as SOHO, where the gravity of the sun and Earth balance